In the context of a European research project called SOPHIA, the Department of Industrial Design at Eindhoven University of Technology and Conante developed a joint user interaction demonstrator for semantic connections. In the semantic connections demonstrator, we are exploring ways to configure a smart environment according to a user's needs. The real payoff of being able to connect smart devices to one another is to support high-level interactions within a smart environment that would usually involve multiple steps on multiple devices. In our first design, we followed a tangible user interface approach, where smart devices in the home are represented by cubes that are used in combination with an interaction tile. The interaction tile shows the connection possibilities with a high level of semantic abstraction, hiding the complexity of wired or wireless networks. By interacting with the objects, semantic connections can be built, redirected, cut, or bypassed. Triples representing the connections between the different devices are inserted into and queried from the semantic information broker of the Smart M3 platform. As an alternative to the tangible user interface approach, we also investigated an augmented reality approach called SpotLight navigation, where connection information contained in the smart space is projected into the real world, augmenting the real environment with virtual information, making it intuitively perceivable for users. To test and demonstrate the interoperability between the two different user interface paradigms, we set up a joint experiment using both the SpotLight navigation and the interaction tile. With SpotLight navigation, devices are identified by their physical location and are also represented by a projected icon. Connections are created simply by drawing lines between the devices. Here the connection between the music player and the sound system is displayed, with the sound system in turn shown as being connected to the ambient lighting. When we then play a song on the music player, the song will also play on the sound system, and due to the transitivity of the semantic connections, also be visualized by the ambient lighting. In our second example, the SpotLight navigation indicates that there is an existing connection between one of the music players and the ambient lighting. We then create a connection between the second music player and the sound system using the interaction tile. The SpotLight navigation reflects this by displaying a green line between each of the two input and output devices. Music can now be streamed independently from each of the music players to the corresponding output devices. Using an ontology simplifies the process of integrating different interaction approaches, as the different entities and relationships in the semantic information broker can now be referred to unambiguously. As communication via the semantic information broker is standardized, integrating cross-vendor implementations are also simplified. What still needs to be done is to automatically track the actual locations of the devices for SpotLight navigation, and to combine the separate prototype components of SpotLight navigation into a full embedded setup. We are also busy generalizing the ontology to enable different types of connections, and to integrate multimodal interaction data in order to enable semantic interaction in a smart environment.